Okay, I want to introduce you today to the topic of pointers. And in order to do that, I'm actually going to start out by calling a normal function and not using any pointers. And then we will build from there as to why we might want pointers and how they can be useful. So in this first example, we're just working with a really simple main function. And so we've got our int main, and we're doing some programming, we're going along. And then we're going to declare this value int a, and we're going to set it to the value 4. And we're going to declare variable int b, and we're going to set it the value 5. And then we have this other int ab, and we want ab to be the product of a and b. And so we're going to call this multiply function, and we're going to pass it a and b, and then it's going to return to us the product of a and b. And so if we go down here, then we just have a pretty simple multiply function. And so here we're declaring that it's going to return an int. It's called multiply, and it's going to take two parameters. So it's going to take int x and int y, and then it's just going to say int product is equal to x times y, and it's going to return product. And so product is going to go back here, and it will be, since it's the return value, then the product will be set to this value a and b. What this actually does, though, is that as main is going through, main has these two variables, a and b, and main does not trust other functions with its data, right? So main says, okay, I need to call this function multiply, but I don't really trust multiply with my actual a and b, so I'm not going to send them the actual variables because I don't know what multiply is going to do with them, but I'm going to send them copies of that variable, or I'm going to send them a different box that has a different integer box that has the value of a and a different integer box that has the value of b, and it can do whatever it wants with those. So instead of sending the actual a and b over to the multiply function, main is going to create a copy, and so it's going to have one integer, and it's going to give it the value 4, and then it's going to have a second integer, and it's going to give it the value 5. And so it's going to take those, or rather the computer is going to take those, and it's going to pass these along to the function multiply, because multiply, when it starts up, it says, hey, I need two integer values. Computer, what do you have for me? So the computer says, hey, I've got these two values, 4 and 5. Can you work with that? And multiply says, yeah, I can work with that. So multiply takes this value 4 and it assigns it to this new integer x. And then it takes the value 5 and assigns it to the new integer value y. And then it computes. It says, okay, I'm going to make a new integer variable called product. And this integer is going to be equal to the product of x times y. And then I'm going to return this new integer product, right? And so it's going to do the same thing. It's going to write the copy down, or it's going to write down the value of this new variable product, and the computer is going to pass that back along to the main function. So main says, okay, I can now take that and I can assign it to a and b. So this whole process is what we call pass by value, right? Because the actual variables aren't being passed, just the value of the variables is being passed. And most of the time, that is exactly what we want to happen, right? Because like we said before, we don't necessarily trust this multiply function. We don't know who wrote it or what's happening or maybe what's going on in there. And maybe somebody kind of messed up and somewhere along here they wrote this function. So after they, calculated the product, maybe they, for some reason, set x equals 0, right? And that's fine because they can do whatever they want within this function as long as they still return the product that we're expecting. They can set x equal to 0, and that only affects the local change, and it's not going to have any effect on our original values up here. So these original variables are going to remain completely unchanged. And so that's the benefit of having pass by value, is that you do not change your original variables. They stay safe from whatever the function might do, and so functions can communicate just by passing the value back and forth. Okay, so let's look at a slightly different scenario. So in this scenario, again, we've got our int main, and we're doing some programming, we're going along, and then let's say that we have some array of floats, and this array of floats is going to hold the stock prices of a bunch of different European stocks, right? So we've got float Euro stocks, and it's a long array. And then maybe let's say that we are located closer to the New York Stock Exchange. So we actually want to convert everything over to US dollars because we're doing everything in USD. And so we want to be able to call some function, convert to USD, that's going to act on this whole array. But if we try to do pass by value again, that's actually going to be a lot of overhead, because instead of just copying two values like we did in the last one, if we're copying the values for all the European stocks, I mean, that's going to be a couple thousand stocks or so. So we're talking about a lot of floats, right? So that's not only a lot of extra memory to take up as we're passing those values back and forth, but it's also just going to take a long time to duplicate all those values in memory. So instead, what we might do is we want to find some way that we can manipulate this array in place, but we still want the logic to be isolated, and we want the logic to be isolated and extracted into a different function, right? So we want to be able to call some function, convert to USD. And also, because we're converting everything to USD, we don't necessarily need to keep the same data. So it's okay if this data gets rewritten, right? It's okay if these values are changed in place. And that's called in place if you change the original values of the array instead of like making a new array with the USD values. So we want to be able to call some function down here, convert to USD float stock array, where for each stock we can go through the whole array and we can multiply it by some conversion factor, USD per euro, and we can assign that back to the original place in that array, right? So we want to be able to do this conversion, assign, if we had stock array 4, equals some value, right? We want to be able to replace stock array 4 with the new USD equivalent. And we want to be able to do that for every single value in the array. And so how do we do this? How could we be able to access values and variables that are inside the main function from a function out here? And so that is where pointers come in. And so to understand that a little bit better, I actually want to talk a little bit about how the memory is working behind the scenes. And I think that this is really going to help us kind of get to where pointers are coming from. So if this is our main function, right? So we're going along, these are all the memory addresses that main has access to. And so in our first example, let's say that the value A, let's say that was in box number 7 right here, right? And so the value of A was 4, and we can say that maybe the value of B was stored in box number 8, and that was 5, and then product was maybe stored down here in box 14. It's not always going to be linear if they're individual items like that, and so 14 was product, and so that's going to be 20. And so when we called this function multiply, this has all its own memory addresses, right? And so when we call this, these memory addresses shadow, or they block all the main addresses, right? So right now we're only working with these. We can't see what's going on back here. We can only see these values that we passed over that then got copied into 4 and 5 right over there in these other new memory addresses. And then we pass back, we calculate that it's 20, we pass it back to main, and then multiply goes away, right? And so main now can't see what happened with multiply. It only knows that 20 came over here. But let's say that we're doing our convert to Euro stocks, or convert to USD function. Well, so what we want to do there instead is we want to be able to not just pass it the value, we want to somehow be able to pass it the memory address. Because if we can pass it the memory address, then this function convert to USD can actually do some work on the original values, right? And so let's say that the Euro array starts in box number 21, and then because it's an array, it actually is going to be sequential, right? So it's going to start at 21, and it's just going to go however long that is. If we, instead of passing the whole array, if we can create a new variable, and one second, if we can create a new variable and we can write the value 21 in here, and this is the address that we're passing over, then now convert to USD, now this function can have access because it knows where the memory address is found. Now it can start working on this data in place. And so this is called a pointer, right? So a pointer is just a box that holds a memory address. And it's a pointer because it points back to these variables and these values in here. So what does that actually look like? Well, so from our example before, so let's say we wanted to get the address of the variable a, right? So then we would say ampersand a equals 7. And so ampersand says, hey computer, tell me the address of the variable a. And the variable a is stored at box number 7. And if we say computer, give me the memory address of b, well, b, which is 5, is stored at memory address 8, right? And then if we want to go the other way, then we can do that. And so we can say, hey computer, what is the value of the variable that is stored at address 7, right? And that is called dereferencing. And so we use the asterisk, and that's called our dereference pointer. And so we say, okay computer, I want you to dereference memory box 7. And that is going to be equal to the variable a, which has the value 4. So then if I say, okay computer, dereference 8 for me, dereference memory box 8, I'm saying, okay, give me the value of the variable that is stored in memory address 8. And that is going to be equal to 5, right? And so we can do the same thing. We can say, okay, computer, give me the address of the variable which is stored at stock array 0, and that is going to be equal to 21. And so this is how we can pass the whole array without having to actually copy the whole array, is we can just say, okay, give me the address of stock array 0, and that's at 21. If I say, give me the address of stock array 3, then that will be at 0, 1, 2, 3. That equals 24. And I can go the other way again. I can dereference this stock array, or I can dereference 21, and that is going to be equal to whatever the euro value is. And so we can come up with a name for this, and this is called a pointer, right? So I can say I have a pointer which is equal to the address of a, and so then that pointer equals 7, and so then if I dereference the pointer, I get 4.